Let's take a look at a specific kind of problem when we have a point on the terminal side of a position angle. So the problem is to find the 6 trig values for theta if the point 12, 5 lies on the terminal side of theta. So we can see on my coordinate plane that I have a circle centered at the origin. That's going to help me for reference. But I want to find the point 12, 5 so that it lies on this circle. And that's going to mean that we have to go over 12 and up 5. That point would be about right here. And that would describe a position angle theta. So here's the initial side of theta, and this would be the terminal side of theta. And if I want to find sine, cosine, and tangent of theta, what I like to do is go back to the most basic definition of sine, cosine, and tangent, and those have to do with right triangles. So on my diagram here, I'm going to identify this right triangle. And the thing is, we know an awful lot about this triangle because of the point, 12, 5. That means that when we found that point, we went over 12 units and up 5 units. And we've created this right triangle. Since we have a right triangle, we can use Pythagorean theorem to find out what that hypotenuse is. And I'm just going to call that r because it's also the radius of this circle. And that'd be r squared is 12 squared plus 5 squared. So r squared would be 144 plus 25, which is 169. And when I take the square root of both sides, I get that r is 13. So that is that length, which is great because now I have a right triangle. So all the values are filled in. It should be easy to find the 6 trig values of theta. Sine would be opposite over hypotenuse, so 5 over 13. Cosine of theta is going to be adjacent over hypotenuse, 12 over 13. And tangent of theta is opposite over adjacent, so 5 over 12. And when we have to find the other 3, the cosecant, secant, and cotangent, we just take the reciprocal of these fractions. So 13 fifths, 13 twelfths, and 12 fifths. So if we generalize this problem so that we're talking about any point lying on the terminal side of some angle, well, any point is also going to lie on some circle centered at the origin. It's going to define a position angle alpha. And so we have our angle alpha going through our point, xy. And that would also define a right triangle that we could draw in by just drawing our vertical down from the point that we're given. And then the base of our triangle would be what lies on the x-axis. And our hypotenuse is the radius of this circle. That creates a right triangle. The base of our right triangle is how far we went in the x direction. The height of our triangle is how far we went in the y direction, and the hypotenuse is the radius of our circle. So we can use Pythagorean theorem. R squared is x squared plus y squared. So r would be the square root of x squared plus y squared. And then we can easily identify all 6 of our trig values. Our sine of alpha is going to be the opposite over the hypotenuse. Cosine is adjacent, the x-coordinate, over whatever the radius is. And our tangent is opposite over adjacent, or x over y. And of course, the cosecant, secant, and cotangents are going to be the reciprocals of these 3 fractions. So r over y, r over x, and x over y. So let's try it again, finding the 6 trig values for theta if negative 3, 4 lies on the terminal side of theta. So negative 3, 4 would be about right here. So our angle theta has its initial side, and its terminal side would go through the point right here. And that makes alpha this angle. When we draw our right triangle in, we always have to bring it to the x-axis. So that's going to mean drawing our vertical side over here. And the base of our triangle is going to be right here to make our right triangle. Now, technically, theta is over here, this angle. However, we're going to treat theta as being this interior angle, the acute one, as a reference for the values for our 6 trig functions. Remember, this is the point negative 3, 4. So the x-coordinate is negative 3, and the y-coordinate is 4. And we need to find this radius. The radius, we said, was going to be the square root of x squared plus y squared. Remember, negative 3 squared is not negative 9, it's 9. And then 4 squared is 16. So we have the square root of 25, which is 5. The old 3, 4, 5. So let's find our first 3 trig values referencing the central angle, theta. And that will leave us with sine being opposite over hypotenuse. Cosine is adjacent, negative 3 over 5. And tangent would be opposite over adjacent. Now, I hope this jumped out to you about cosine and tangent is we've got 2 negative numbers for those values. And that's okay. We can have a negative value for cosine and a negative value for sine because this obtuse angle, theta, makes the terminal side lie in the second quadrant. But let's finish it up by finding the reciprocals. Cosecant would be the reciprocal of sine. Secant is a reciprocal of cosine, so negative 5/3. And cotangent would be the reciprocal of tangent, negative 3/4. Let's try it again with the point negative 9, negative 1. First, find the point on a circle, so about right here, negative 9, negative 1. Next, draw that angle in there. We have our initial side on the positive x-axis, terminal side goes through that point, so here's theta, going all the way around here. That's going to define a right triangle. So draw that right triangle in next. Since we were talking about the point negative 9, negative 1, those are going to be the lengths of the base and height of the triangle. Next, we need to find out what the radius is. And the radius is the square root of negative 9 squared plus negative 1 squared. 81 plus 1 is 82. So r is going to be the square root of 82. Now that we're looking at a nice right triangle, here's a right angle. We're going to think of theta being over here, this central angle. And so we can identify sine, cosine, and tangent. Sine is the opposite over hypotenuse. And we should simplify this so that we rationalize the denominator, and that would be negative square root of 82 over 82. For cosine, that's adjacent over hypotenuse. Rationalizing that denominator, we end up with negative 9 root 82 over 82. And for tangent, it's opposite over adjacent. And of course, negative over negative is positive. Then when I look for their reciprocal identities, I'm not going to use that last fraction that I made, but actually the first fraction. Because when I take the reciprocal of negative 1 over square root of 82, I'm left with negative square root of 82. And for the reciprocal of cosine, secant, then negative 9 over square root of 82, when I take that reciprocal, the square root goes on top. And so we'll already have a rationalized denominator. For tangent, I will take that last one because there's no roots in there. And the reciprocal of 1/9, of course, is 9. One other thing to notice here is that when we are in the third quadrant, again, we did have negative values. We had a negative for sine and a negative for cosine. However, tangent this time was positive. Well, we did the other three quadrants, so we might as well do this one too. And let's take a look at a point 6, negative 10 being on the terminal side of theta. So if we went over 6 and down 10, approximately over here. So we're going to draw that angle in. Next, we draw in our right triangle. So I'm going to draw a vertical line to the x-axis, and the x-axis being the base. Right, so the radius of this circle is going to be our hypotenuse. Of course, since we're at the point 6, negative 10, the x-coordinate was 6, the y-coordinate was negative 10, and we need to calculate the radius. So r is the square root of 6 squared plus negative 10 squared. So square root of 136. And I know that 4 goes into 100 and into 36, so square root of 4 is 2, and we'll be left with square root of, well, it goes into 125 times and into 36 9 times, so 25 and 9 make 34. That's going to be our radius, to square root of 34. All right, now we're ready to find our 6 trig values. And when we want to find sine, cosine, and tangent of theta, you know, we've been thinking of theta as always being this positive angle, but there's actually nothing in the problem that says that it is. It just says that the point 6, negative 10 lies on the terminal side of theta. So maybe theta is this negative angle. And then we are dealing with an acute triangle. But anyway, the sine of theta is going to be opposite over hypotenuse. And we need to simplify this fraction. So first of all, that'll cancel, leave us with negative 5. And we rationalize the denominator, so we're at negative 5 root 34 over 34. For cosine, that's going to be adjacent over that hypotenuse. Some similar canceling, that leaves us with 3, so we'll have 3 root 34 over 34. And then for tangent, it's opposite over adjacent. 2 goes into both of them, negative 5 and 3. So we have negative 5/3. And we'll finish up by finding the reciprocals. So I go back through my work, really, take the reciprocal of that, and we'll have root 34 over negative 5. And for secant, we will have the square root of 34 over 3. And for cotangent, being the reciprocal of tangent, we'll end up with negative 3/5. Again, we still have negative values, right, for the sine and for the tangent. I hope that you noticed this, that when we were in the first quadrant, everything was positive. When we moved over into the second quadrant, that's when we started getting some negative values. And we got a negative value for cosine and a negative value for tangent. So that means that sine was the only thing that was positive. When we were in the third quadrant, sine and cosine were both negative, but tangent is what stayed positive. And in the fourth quadrant, it was tangent and sine that were negative, so its cosine was the only thing that was positive. That might be helpful in the future.